This real-time stock market dashboard requires less than 100 lines of code. It pulls real-time and historical stock data from the Yahoo Finance API, and the interactive user interface is generated using the Streamlit library. Based on several parameter options, the dashboard can visualize minute-by-minute changes in stock prices using a candlestick chart. The user can also overlay indicators such as the moving average to understand broader stock price trends. Overall, this dashboard is a good starting template for a more comprehensive stock analysis and prediction tool. You could feasibly build in additional features such as real-time stock price forecasting as well as comparative stock price analyses. Over the next few minutes, I'm going to share how to build this stock price dashboard in Python, which can serve as a framework for an automated and interactive tool for gaining stock market insight. The Python code consists of several functions that will pull the stock price data, process it for visualization, and create enhanced technical indicators to overlay on the chart. These functions are then incorporated into the layout of the Streamlit app to create an interactive user interface. Let's start at the top of the code where we first import the relevant libraries, including the Y Finance library to pull the stock data and the Plotly library for data visualization. Next, we create our functions. The fetch stock data function here uses the Y Finance library download function to choose a ticker symbol, a time period to examine, and the interval at which to display data. For various reasons, the 1-week time window requires additional pre-processing. So I use an if-else conditional statement to fetch the data according to whether we look at the 1-week time window versus the other time windows. The next function formats the date and time characteristics of the pulled stock time series data. This is especially important for the minute-by-minute view of the stock data. Next, we calculate metrics such as daily, weekly, monthly, or all-time low and high values of the chosen stock, as well as the percent change of the interval and the total volume traded. And finally, we use the technical analysis Python package to create a few moving average metrics, here a simple and an exponential moving average. Now that we have our functions defined, we can use Streamlit code to define how the user interface will work, as well as sequentially call our functions to ultimately generate the visualization. We begin by setting the dashboard to wide mode and give it a title. Next, we create parameter inputs in the sidebar. For stock ticker, we use a text input box. For the time period, we use a select box with 5 options. For the chart type, we use a select box with 2 options. And for the indicators, we use a multi-select to allow multiple indicators to be visualized in the same chart. Next, I create a dictionary that translates the time period options to time intervals. For instance, for the 1-day view, I want to view the stock at 1-minute intervals. The values from this dictionary, which are chosen by their keys in the sidebar, will be used as a parameter in the fetch stock data function. But right before we call that function, I use an if statement that will conditionally run the following code in this section if a button titled Update is clicked. We then nest the rest of the code within the if statement. I start by calling the fetch stock data function with the parameters chosen by the user in the sidebar. We will save the results to an object called data, which will then be sequentially edited based on the prior functions we created. First, the process data function, and second, the add technical indicators function. Next, we use the calculate metrics function to create several objects, such as the last closing price of the stock and the percent change in the closing price since the previous time interval. At this point, we have completed the data processing. The rest of the code will primarily control the formatting and layout of the Streamlit dashboard app. I first add a metric element with the st.metric function that will show the current price of the stock, as well as dollar and percent change between the current time and the last closing price. I use f-strings to customize the format of these values. F-strings allow you to output object values within strings by using an F prefix prior to the first quotation mark, and then using curly brackets around the object name. Below this first metric, I also display the stock price high, low, and volume as 3 separate columns. I use the stColumn function to create 3 columns, and then I use the code here to set the order of these metrics. The next section generates the data visualization with Plotly syntax by using an if-else statement to create either a candlestick chart or a line chart based on what the user chooses. Below this, I use a for loop to run through the list of chosen indicators, which then conditionally adds each indicator to the chart using Plotly code and if and elif statements. Finally, the code chunk below formats the text of the graph as well as the output dimensions. This is followed by the Plotly chart function to add the chart to the dashboard. to provide additional information for the dashboard, I then also add to the display the data frames for the historical data and the technical indicators. We might want to know the broader context of other important stock prices when looking at the specific stock we chose. This final bonus code here uses our created functions, a for loop, and an if statement to add additional real-time stock ticker data for additional companies that we want to choose. We have now created a real-time stock price and trend dashboard that can be further customized based on your goals, whether that is to examine past performance of stocks and portfolios or to build in predictive time series models to forecast future values. If you found this video useful, leave a comment, like, and subscribe to the Deep Charts channel for more videos on using data science techniques to analyze and visualize financial markets.